My name is Martin Christ. I work for the West Virginia Department of Environmental Protection in the Watershed Improvement Branch. I'm here in the Buxton and Land Street building in Thomas, West Virginia with the Friends of Blackwater. And we're going to talk about sampling and processing water, especially sampling for the purpose of understanding acid mine drainage. We are explaining this as if we had just come in from the field, and what we did in the field is we filled these 2 bottles of water from various streams and various tributaries and various seeps of mine drainage or other water that we wanted to know what was going on with. We filled these 2 bottles very carefully, being careful not to put our fingers in the rim or to smudge up the inside of the caps so that we don't contaminate that water at all. And now what we want to do is distinguish what was dissolved in the water from what was just floating in the water, what we call suspended. So after coming back from a sampling day, we have a bunch of pairs of bottles like this full of water and bottles like this full of water. On some runs, for instance, we come back with 17 pairs of pairs of bottles. Friends of Blackwater does not have the capacity to measure concentrations of iron and aluminum and some other chemicals in their own building. So they have to send it off to a nearby laboratory and say, hey lab, we'll pay you X if you will tell us how much dissolved aluminum or how much total aluminum there is. Why do we need to distinguish total from dissolved? And there's a math equation here. We've got total material. Let's say iron, for example. Total iron, and then a portion of that is dissolved. Well, the portion that isn't dissolved and isn't this portion here between total and dissolved we'll call suspended. So we have total iron, dissolved iron, and suspended iron. Why do we need to know the difference? Well, there are a few reasons. Some of them deal with chemistry, and some of them deal with the laws and rules that we have for water quality. First, let's start with chemistry. We're dealing with very acidic water. And as you probably know, as you add H plus to water, the pH goes down. So pH 7 is completely neutral. pH 5.5 is neutral, but with the atmosphere's carbon dioxide influencing the pH. And then if you go below that, you start needing other acids to account for why it's so acidic. If you have some minerals in there, and you keep adding H+, the pH may go down slower, but there will still be just as much acidity in there. And that's because the dissolved minerals hold the acidity. So for instance, if I had an iron oxide mineral in the water, and I kept adding H+, the pH wouldn't go down as fast, but it would dissolve some of that iron mineral into the water, and some of the acidity would be contained in the dissolved iron, and some of it would be contained in the H+. So one of the reasons we filter is to know how much dissolved iron there is, and then we can add the dissolved iron to the H+ and calculate total acidity. Another reason is that dissolved metals may have their special effects on biology. For instance, dissolved aluminum is toxic to a lot of fish, and a lot of fish at certain stages of their lives.